Hello everyone, welcome back to Shabest online tutorial. In today's tutorial, we're going to learn how to find the mean and the variance of binomial distribution using probability generating function, PGF. So what do we do first? First of all, we say x is distributed binomial Bn into parameter r, p. And the probability of x, which is the function, is the same as what? Probability of x is equal to x is the same as what? N combination x p raised to the power of x q raised to the power of what? N minus x, where x ranges from 0, 1, 2, then up to n. And the probability generating function, which is represented by g sub x of s, is the same as what? Summation of s raised to the power of x, then multiplied by probability of x is equal to x. So this is going to give us what? Summation of x s raised to the power of x. Probability of x is equal to x is the same as what? N combination x p raised to the power of x q raised to the power of n minus x. So how do we do from here? We have what? G of sub x of x, which is generating function, is the same as what? Summation, as we have s raised to the power of x and p is raised to the power of x. So since their power are the same but the base are not the same, we're going to multiply the base, then we pick one of the power. So we have n combination x, then p multiplied by s is going to give us ps, then all raised to the power of x, then q raised to the power of n minus x. So what do we do? Remember that this summation x is ranging from 0 to n. So we're going to take the summation. G sub x of x is the same as what? If you take the summation starting from s is raised from 0, at s is equal to 0 is what? N combination 0, then p s raised to the power of what? 0, q raised to the power of n minus x, then plus at s is equal to 1 is what? N combination 1, ps raised to the power of 1, then q raised to the power of what? N minus 1. This is n minus 0. In place of x, we replace 0. Then plus up to at x is equal to n, which is going to be what? N combination n, ps raised to the power of what? N, then q raised to the power of what? N minus n. So g sub x of s is equal to what? When you simplify the whole of this, it's going to give us what? P s plus q all raised to the power of n. So this is the generating function of this binomial distribution. Now we are looking for what? Mean and the variance of a generating function using mean and variance of a binomial distribution using probability generating function. So what do we do? Mean, which is the same as what? Expected value of x. So mean of a probability generating function is the same as what? G sub x of s at first derivative. So at first derivative imply that we are going to differentiate this function, this generating function we have, once. When we differentiate once, it's going to be our mean. So the mean is the same as what? G of s at first derivative sub x is the same as what? When we differentiate this using power rule, this n is going to multiply this bracket. We are going to have what? N into the bracket of p s plus q, then raised to the power of what? N. Then we take away 1 from the power. If you recall your power rule of differentiation, remember we are differentiating with respect to s, then we have s here. So if you differentiate the p there, ps, 1 multiplied by p is the same as p, then p 1 minus p 1 is 0, s raised to the power of 0 is the same as p. Therefore derivative of ps inside this bracket is the same as what? Is the same as p. So the next thing we're going to do, we have g at first derivative of s sub x is the same as what? N multiplied by p is np, then ps plus q raised to the power of n minus 1. But recall that the whole of this here is the same as 1, because when you substitute g prime of x at x is equal to 1, it's going to give us what? N p then into P. In place of S here is 1. When you replace 1, it's going to remain only P. Then plus Q raised to the power of n minus 1. To show that this is equal to 1, this P plus Q, remember that Q is the same as 1 minus P. So therefore, inside this bracket is going to be imply P plus this Q is the same as what? 1 minus P, and all to the power of n minus 1. This is negative P, this is positive P. This is going to be give us what? 1 raised to the power of n minus 1, which is the same as 1. So therefore, the whole of this quantity here is 1. Then 1 multiplied by np. Therefore, the mean, which is g prime at first derivative sub x of s, is the same as what? Np, because np multiplied by 1 is the same as what? Np. So having getting the mean, the next thing we are going to look at what is the variance. And we know the variance of a probability generating function is what? Variance of x, which is equal to what? G at second derivative of x of s plus g at first derivative of x of s minus g at first derivative of sub x of x, all raised to the power of 2. So this is the variance. This is a variance, but recall that all this s is going to be at x is equal to 1. So what do? You remember we have solved for g at first derivative already, so we have what we are going to substitute here and here. Now we're going to look at the generating function at the second derivative of sub x of x, which is going to be equal to what? To get the second derivative, we're going to redifferentiate this. So if you differentiate, we're going to have what? N P into what? N minus 1. When you use this to multiply this, then into the bracket of what? Ps plus q, then raised to the power of n minus 2. When you take away minus 1 is the same as minus 2. Then multiply by, we differentiate inside bracket because we are differentiating to respect to s. So if you differentiate, we are going to have p. Derivative of ps is the same as p. So what are we going to do next? Then we substitute at what? S is equal to 1, then sub x, which is equal to what? Np into n minus 1 into, if you substitute 1 here, it will be p, then plus q raised to the power of what? N minus 2, then multiply by p. So what do? We're going to expand this. We have what? Np minus n is going to give us what? N square p, then minus np minus np multiplied by minus 1 is going to give us np, then multiply by this p here, then into the bracket of p plus q raised to the power of n minus 2. Now we expand this bracket. We're going to have what? N square multiplied by n square p multiplied by p is n square p square minus np multiplied by p is going to give us np square. Then the whole of this is going to be equal to 1. So therefore, g as second derivative sub x of x is equal to 1 is the same as what? N square p square minus np square. So recall that the variance is at second derivative plus at first derivative minus at first derivative all square, but s is the same as 1. So therefore, the variance of x is equal to what? At second derivative, we have n square p square minus np square, then plus what? Plus at first derivative, which is np, so we substitute np, minus at first derivative all square, which is np all square. So we simplify this. N square p square minus np square plus np minus, if you simplify it, you are going to have what? N square p square. So we have negative of n square p square here, and this is positive of s square p square. So this and this is going to cancel. So the whole of this can also be rewritten as what? np minus np square. So I write this one first, then minus this. So what do we notice? We notice that np is common, both the left and the right hand side of this expression in the right hand side. So we factor out what? np, then np divided by np is 1, minus np squared divided by np is going to remain only p. So what do we do next? np. Recall that 1 minus p is the same as q. So 1 minus probability of success is the same as q. Therefore, in place of 1 minus p, we are going to replace q. So therefore, the variance of a binomial distribution using probability generating function is equal to what? NPQ, while the mean is NP. So this is how to find the mean and the variance of a binomial distribution using probability generating function PGF. Thank you for watching, and please follow us for more videos like this. Thanks.